So we're going to be talking about molecular orbitals, and we're going to be working on some problems. Molecular orbitals, or electron configuration, is the study of how likely electrons are to be in a certain region and what gives the shape of the molecules, etc. So we have different configurations. We have S configurations and P configurations. In S, we draw it as if it was a circle, and we have three different kinds of P's: Px, Py, and Pz, similar to like a coordinate plane where you have the x-axis, the y-axis, and then we have the z-axis. And we see that here with sp orbitals, which are typically triple bonds. Well, they are triple bonds. We have S, we have P, which is the px, and then we have that it comes out as 180 degrees, and it looks like this, kind of like a figure eight. P2 is typically with two P's, S, Px, Py, which is those are our two P's, and then we have them come out as 120 degrees, and we give this triangular type shape. And sp3 has the three P's: Px, Py, Pz, and it comes out 109.5 degrees, and that's sp3. sp2 are like our double bonds, and sps are our single bonds. So, double bonds are written as we call them our double bonds. We call them pi bonds, and single bonds we call them our sigma bonds. And our triple is 2 pi's, 1 sigma. Well, our double bonds are 1 sigma and 1 pi. We call them what makes it double O is the pi. So here we have this alcohol, and our first step to drawing out the orbital overlap and orbital configuration, first we want to draw this out with all the hydrogens, all the carbons, and all the electrons. So we're going to do that. We have our central carbon first. We have these two carbons, and then we have the O, and that's attached to an H. And this has 4 electrons. This one, carbons, we don't indicate the hydrogens. It's assumed that they're attached. Any other molecule, we have to have it explicitly stated that there are hydrogens attached. But for carbons, we don't explicitly state them. It's pretty much a given. So that's why when they're not labeled, if they're not labeled here, we just put electrons. If they're not labeled here, we put hydrogens. Okay, so that we have all the hydrogens, all that. So let's go here, and we have our central carbon, and it's going to have 3 P's. Now this carbon here bonds to it as such, and we shade it in. Same with this carbon. And this carbon has 3 P's overall. Now we draw the hydrogens on these. Well, this one actually has, sorry about that, 4. My bad. For the hydrogens, we just draw a little circle, and that indicates that it's a hydrogen. Now we're going to draw oxygen, and that's going to bond here. We should actually shade these in as well. Just to be a little extra. And now here we're going to draw its bond with hydrogen, and then we're going to draw our 2 electrons and put them in their own little cloud. So that's this one. Now our next one is, do you remember this functional group? It's a ketone. Our next one is this ketone. And we're going to do the same steps. We're going to draw everything out. We're going to draw all the hydrogens, every single hydrogen. And double bonded to this oxygen that has 6 electrons. So now we're going to transfer this over to this. Well, so now we're going to use this information and we're going to apply it here. We have our central carbon. We have our 4 P's. This one we already know is our hydrogen. And these are going to be our 2 other carbons. And they're going to each have 4 with hydrogens. 4 in total, 3 P's with hydrogens. And this one is going to be bonded to an oxygen. And this oxygen is going to have 3 electron clouds. But we're not done there yet, because this has a double bond. So what do? Let me get another marker, and I'm going to indicate the p orbital, the other p orbital. So here, this is how we make our pi bond. We're going to pull out this long p orbital, and we're going to make another one here. And we're going to try to make them parallel, because that's how these guys bond. And we indicate with a dash, and we write pi. And then on this one we write sigma. And that's how we do that one. Now this last one, our alkyne triple bond, we want to be careful here, because this right here, it's not just one big line that's triple bonded to oxygen. This is a carbon triple bonded to another carbon with a single bond to hydrogen. So we're gonna show that carbon triple bonded to another carbon, single bonded to an oxygen, single bonded to a hydrogen. Here we're gonna this one is complete octet. It has 4 bonds, can't have any more. This one has a hydrogen. So now we use this information and we bring it on over here. We have our carbon and we have our other carbon. And this one is bonded to hydrogen. This one is single bonded to an oxygen that has a hydrogen. But here we want to add p orbitals. make them parallel. If we do them any other way, then they wouldn't bond. Here we indicate pi. But this here is a double bond, so we want to add another one. Again, we want to make them parallel. These two are parallel to each other. And again, we draw pi. And for this one, we draw sigma. And that's how you do the 3 types of bonding to demonstrate molecular orbitals.